My name is Scott Nowicki, and this is the basic tutorial for JMARS. If you go to the JMARS website, jmars.mars.asu.edu, this is where you will generate an account and log in to then download this software. So step one is to actually generate an account. So down here there's a button that shows Create New Account. If you click on it, it will take you to very simple information that you have to plug in order to get an account. Once you've registered an account, the servers will send you an email response and letting you know that you can actually download and install JMARS. So the installers are here. So there's the JMARS cross-platform web start installer. That's probably your best bet. All right, once you've downloaded it and installed it, starting it up is relatively easy. There should be an icon on your desktop. If you double click on that, it will open up the login to the servers. So I will log in. And given that the internet connection is pretty good, it should fire up relatively rapidly. There are two main windows to JMARS. On the left-hand side is the Layer Manager, and on the right-hand side is the Display window. So what we're going to do is load up layers in that Layer Manager to then view in this Display window. The first thing I would like to load up is the Nomenclature Layer. That's effectively the geographic names of the features on the surface of Mars. So I'm going to click on Add a New Layer and go down to Nomenclature. Once the nomenclature appears and it's green, showing that the data is there and available, you see these names appear in your window. If you double click on the nomenclature layer, you can see that we have quite a few options, that we don't have to look at all names at the same time. We can actually choose specific names of specific landmarks. So to begin with, I want to choose the MER 2003 lander opportunity location, which was actually in Meridiani Planum. So I'm going to choose Planum as my features, and there you can see that Meridiani Planum appears relatively close to 0, 0 on the surface of Mars. All right. If on the other hand I want to choose the Mars Science Laboratory landing site in Gale Crater, I will have to select craters. We have lots of names of craters on Mars. So under navigation, you can see the landmark type crater is listed. When you choose the landmark, you actually have to choose the name. So we'll zoom down to the G's, and there is Gale. If you hit Go To, it will take you to Gale Crater. So we've panned over the surface of Mars to the correct location. On the right-hand side is this zoom choice, so where you bumped it up to about 128 pixels per degree, so we can see Gale Crater dominating the window. All right, the next layer that I would like to add is a MOLA, which is the Mars Orbiter Laser Altimeter colorized elevation. What we're currently seeing is the grayscale elevation. So if we go down to Maps by Instruments, there is the MOLA. And I'll actually go all the way down to the shaded relief and colorized elevation, and we're going to view that graphic data. So you can see that as it loads up, there was a red button there. As the data gets dumped in, it turns green. I'm going to add two more layers. Both of them are going to be a THEMIS. And THEMIS is the Thermal Emission Imaging System. I want to load up the daytime IR mosaic. And I'm also going to add the THEMIS nighttime IR mosaic. All right, so now we have two global data sets sitting on top of the MOLA colorized elevation. So what you can see that within this layer manager, there's an M and a P, and the M stands for the map view, and the P is the pan view. It's this lower window. So what I'm going to do is nighttime, and that's what we're looking at, nighttime temperatures. I can turn that on and off by clicking on the M button. So when I click on it and that line appears, that means you're not viewing it in that map window. So that's one good way to compare multiple data sets, just to turn them on and off. And the other is using these opacity sliders. So currently the upper layer is at 100% opacity. I can take it down to 50%. I can take it down to 0%. So yet another good way to visualize between data sets. All right, now the layers themselves can be switched around. We can actually grab that daytime and drop it on top of the nighttime, so you can do the opposite. It's totally up to you as to how you want to display all of these different layers. All right, now in addition to actually seeing graphical information, we can actually use numerical information as well. So for that, I'm going to actually add the MOLA again, and I will actually do the MOLA 128 pixel per degree elevation. And now you can see that there isn't any view graphic data, it is more numerical data. So I'm going to click on plot numerical data, and there's a new layer that appears. Now notice that nothing has changed within my viewing window. So once you double click on that feature or on that layer, you can see that there's actually a plot that can appear. On the left, or on the y-axis is elevation, and on the x-axis is distance along a line. So in order to create a plot, you can just click once and double click at the end of your line, and all of a sudden you get this elevation profile across Gale Crater. Now, one entertaining thing to notice is that, well, the south rim of Gale is very high, some almost as high as 1,000 meters above the surface. The south rim is significantly lower, about 1,700 meters below average elevation, and that mound of material in the middle of Gale is actually higher than the northern rim. So as we slide back and forth, we can see that the little yellow mark shows us where we're looking at on the profile. All right. If you are satisfied with that, you can easily shut off that layer by clicking on the M, and your plot disappears. Of course, if you are not interested in keeping that plot, you can delete that layer, and you can, of course, delete any of those layers as they appear in your list. All right, the last thing that we want to do is actually collect some other numerical information. So I'm going to actually choose tests, and we're going to do test albedo. And you can actually do plot and view graphic and numerical data. And the best way to do that is to plot and view numerical as we wait for it to load. There is the information, and it has numerical information to it. So therefore, as you move your cursor around, you can actually see the values both in the pixel, and it tells you the number. So looking at Gale, we can see that there is a dark feature, and let's turn this down a little bit so we can see what's going on, that there are some dark surfaces to the south of Gale, and it kind of gets brighter as you work your way further north. If we want to actually plot that out, once again, we can click on that and go to chart, and we'll generate that line again, and there is our plot of numerical data. So we can both view this numerical, whether by using your pixel on the surface or by actually creating a plot. If you want to save this plot in order to turn in with your write-up, all you have to do is right-click on the plot and save as. It's a PNG that is actually generated from it. So we can call this Gale albedo and save it. All right, now what we might also want to do is actually save an image from this. So if we go back to main, I'm going to turn off that albedo plot, and instead we're going to capture this viewer window to JPEG, which is relatively simple. The same thing. This will be a JPEG file, so we will call it Gale, and we're actually viewing daytime IR. We can save that image as a JPEG. If we now look at our desktop, here is our new JPEG image suitable for publication. And that concludes the basic tutorial for how to use JMARS.